Hello, everyone, and welcome to Invitation to Puzzles, where today we have a Region Sumlines puzzle by AFrayedKnot. Let me talk about how Region Sumlines work. I think this is the second Region Sumlines puzzle on the channel, although my my record of claiming that in the intro to a video and it being true is very bad. Very, very bad. But let's give it a try. See what we can find. So I think this is the second one, and let me explain how this works. I will say that Region Sumlines are one of my favorite Sudoku mechanics. So what Region Sumlines do is they express that the line, the nice cyan blue line, if you will, is split into pieces by the box borders. That's why it's region sumlines. It's because the boxes in a Sudoku are called regions sometimes. For example, this line gets split into the yellow part and the green part. And what makes it a region sumline is that the yellow part and the green part have the same sum. That's true of every line in the grid. However, different lines can have different sums, or different lines can have the same sum. There's just no connection between what the sums are across the various different lines through the puzzle. Okay, so in particular, if you want help thinking about that, one way that you can think about that, if you've seen arrows before, is that this region sum line here is just literally an arrow. If you think about there being a circle here and an arrow pointing in here, it's just saying that this digit is the sum of these three digits. However, these are much more general than arrows in a sense, because with an arrow, you couldn't say these two have the same sum as these five, for example. Alrighty, so let us do our level best with this puzzle. There's a link down in the description if you want to try it. And let's go ahead and get to it. So a pattern that you will see in almost all, not all, but many, maybe probably way more than 50% of region sumline puzzles is you'll see an arrangement that looks kind of like this, where what you're being told is that the sum of these two cells is equal to the sum of 5 cells. And it's specifically the 2 cells having the same sum as 5 cells part that I am interested in here. And the reason for that is because the minimum and maximum are very close. So the minimum of 5 cells is 15. If it's 1, 2, 3, 4, 5, that's what you get. The maximum of 2 cells is 17, if it's 8 and 9. And so you only have a little bit of wiggle room. If you want, you could say you have 2 degrees of freedom, if you want to use fancy language about it, just to say that you have sort of 2 amounts of wiggle that you can do between the maximum and the minimum overlapping. But at the very least, it does tell me something, which is that these cells need to each be at least 6. If either of these cells is, say, a 4, like let's imagine that's a 4, well, now the maximum sum of these two is now 13. Well, these sum to more than 13, so they're not going to have the same sum. Okay, and so the minimum I can get, because 6 plus 9 is exactly 15, the minimum I can do is 6. The key thing to note here is exactly the same words are true about this little gidget over here, where I again have 5 cells being equal to 2 cells. So these are also from 6, 7, 8, 9. Right. Now, either of these separately have lots of options. So if I was only looking at this or only looking at this, I'd have lots of flexibility. But actually, the way these two things are put together, we have no flexibility left. And that's because these cells within this row, they are 6, 7, 8, 9 quadruple. It's 1, 6, 1, 7, 1, 8, and 1, 9. Which means I know there's some, because I can just add 6 plus 7 plus 8 plus 9. And if you don't want to, I'll just tell you, it's 30. And so even though sort of ostensibly these could have added to 15, 16, or 17, and these could have added to 15, 16, or 17, the fact that these all together add to 30, and each of them is separately at least 15, means they both just have to be 15. which means that if I go ahead and plonk a yellow on these, the yellow cells, you can say just sum to 30, which is their literal minimum. If I take 1, 2, 3, 4, 5 here and 1, 2, 3, 4, 5 here, well, that is exactly 30, which is the minimum I could possibly do. So you can think about this deduction in a couple different ways, but the key thing to notice is how these two interact with this 2 equals 5 business. Okay, now, because I have 1, 2, 3, 4, 5 quintuples in each of these boxes, it probably will be in my interest to write a 6, 7, 8, 9 over here. And now I can notice that has in fact given me a 6, 7, 8, 9 quadruple in this row. So these are 1, 2, 3, 4, 5. And now that's very interesting, actually, if you look at it, because these digits are huge and these digits are tiny, and yet these two things need to have the same sum. I'll go ahead and give them colors just so that we have green is equal to orange here. What's the minimum sum of green? The minimum sum of green is 6, 7, 8, which is 21. Small math trick if you want. If you're trying to sum 3 consecutive digits like 6, 7, 8, you could just triple the middle digit rather than adding them together. So, for example, the middle digit here is 7, triple that is 21. That's because if I sort of imagined myself moving 1 from the high digit to the low digit, it would turn this from 6, 7, 8 to 7, 7, 7. Anyway, you fairly often have to do something like that, like sum 4, 5, 6 in a Sudoku puzzle, and so saying like, that's just 15, it just saves you a little bit of time. Okay, so the minimum sum of these is 21. What's the maximum sum of these? Would you believe me if I told you it was 21? Which it in fact is, because if these are 3, 4, 5, and that's a 9, that's 12 plus 9, that is 21. And so we actually have to have that world. These are maximized at being 3, 4, 5, and that's a 9, while these are minimized being 6, 7, 8 exactly. Okay, now notice that 3, 4, 5 knocks 3, 4, and 5 out of these cells, which is quite interesting. And if we look closely, it also puts pressure on this thing, this one is, again, really an arrow. It's just saying this digit has the same sum as these 3. Well, what's the minimum these 3 can sum to? Well, owing to this 3, 4, 5 triple, it's now 1, 2, and 6. And the 6 throws a real spanner in the works, because that makes the minimum already 9. And if the minimum's already 9, then that means that these have to be 1, 2, 6, and that has to be 9. Now, do you remember when I said there was a triple of 6, 7, 8 in the row? Maybe I didn't say that. But there is a triple of 6, 7, 8 in the row, so that means none of these are 6. So these are a 1, 2 pair, and that's a 6. In fact, actually, if you look at it, this 6, 7, 8, 9 triple means that's a 9. I could have filled that in right away. This 1, 2 pair sees across all of these cells and says none of these are 1 or 2. Okay. We also have very similar pressure happening in row 4, where we've got our 6, 7, 8, and 9. And so we've got this digit is small. I mean, it's at most 5. But on the other hand, these two digits have a sum which is big, because they're both big. So the minimum sum of these two is 13. What's the maximum sum of these two? Well, owing to this 9, actually, it's 5 plus 8, right? Which is 13. So actually, the only way this works is if these are 6, 7, that's an 8, this is a 5, and that's an 8. So we actually learn exactly what the composition of this region's sum line is by playing this game of what's the maximum and what's the minimum. And now it's important to remember we knew each of these separately summed to 15. And so one of them was 6, 9, and one of them was 7, 8. And this 8 tells me which is which. So this is 6, 9. This is 7, 8. And we can get rid of all the 5s in this row, of course. Get rid of the 8 there. Okay. This puzzle is flowing very nicely. This is what you sort of hope for out of a puzzle. Let's see. Okay, we've got 1, 2, 3, 4, 5. So these are just 7, 8. That's what's left in this row / in this box, whichever one you'd rather look at. And this digit, I know actually quite a lot about, because it's the sum of 3 digits, so it has to be at least 6. But I know which digit it is, because it's not 6 or 9 or 8, so it can only actually be 7. So that gives me my 6 and my 7 over here, which gives me my 7 over here. And also, there's only one way to make 7 as a sum of 3 different digits, which is 1, 2, 4. So actually, these are a 1, 2, 4 triple, meaning that's a 3. And now, actually, if I want, I can do my little Sudoku reflex here of this is a 1, 2, 4 triple in the column. So that's not a 4. And one of these two is a 4 in that triple, so this isn't a 4. And now these two digits are huge, because I've used all of 1, 2, 3, and 4. So these are actually a minimum of 5 and 6, which means that the sum here is a minimum of 14. So what's my maximum sum here? I think my maximum sum here is actually is 15. Because it would be 6 and 9. I don't think there's a reason immediately why this can't be 6 and 9. However, there's definitely a 9 on here, is the way to think about it. Because if I don't put a 9 on this line, well, I can't put a 7 or an 8. And so the maximum this could sum to would be 6 plus 5, which is 11, which is nowhere near enough. So there's definitely a 9 on this line. And because of that 9, I actually know where that 9 is. It's there. Let's see. We can look at Sudoku on 9s into this box. That's not a 9 because of that one. So one of these two is a 9. I can take a second and ask myself if there's really any world where this is a 9. And I think the answer is no, because if this is a 9, those two 9s basically cancel out. And so we'd be saying these two digits have the same sum as that digit. But these two digits sum to a minimum of 8. Because remember, we've used the 1, the 2, the 3, and the 4, so this would be a minimum of 5. But this can't be a minimum of 8, because the 7, the 8, and the 9 in the box are all spoken for. So actually, the 9 is even placed. Now, if you asked, did that do anything? Well, maybe a little bit, because I'm going to repeat the game, and now ask, okay, so now where does the 8 go in box 5? And it's going to go in one of these two. So I'll ask myself, can this really be 8? And so if this was an 8, the minimum sum of this line would become 8 plus 5 plus 3, which is 8 plus 8, which is 16. This would need to be a 7 or more. It still can't be. So that can't be 8. And so that is, which looks up and gives me the 7 and the 8 up there as well. So we've got all of that. Okay. Now I can at least write in what the minimum this digit is, or can be is, because again, this is 3 plus 5 plus 6 is 14. So this needs to be at least 5, and it can only be 5 or 6 because 7, 8, and 9 have gone in the box. So can write this as a 5, 6. In fact, if we are very careful, we can actually do some more Sudoku in this box, which is to ask now where the 6 goes in the box, because we've got the 6 pointing downward here. Can only go there, which has made this a 5, which means this sum is 14, so this sum needs to also be 14. And in fact, we know how to do that, which is to make this a 5. Note it's totally okay that there's two 5s. They basically cancel because 3 plus 6 is 9. Totally okay. Okay, and so this last digit here must be the 7 for the box. Let's see, that is perfectly nothing-y. Great, great. I have also seen that all that is left in this box is 1, 2, 3, 4. So the maximum sum of these digits, for whatever that's worth, is 9. It's not very high. These are also, by the way, in this column, we've used the 5, the 6, the 7, the 8, and the 9. So these are also from 1, 2, 3, 4. It can be worth marking, whereas these are from 3, 5, 6, 7. Looking at the column, because we've got the 1, the 2, the 4 going already. I was trying to play these against each other, but I don't think I'm quite going to get anything out of that just yet. Let's see. There's definitely a 6 over on this line just by Sudoku. I don't know how useful that is. This is a 1, 2, 3, 4. I don't know how useful that is either. Let's see. Okay, well, this line sum has got to be really small, actually, because if you just look at the column, all that's left is 1, 2, 4, and 5. And the 1 and 2 are definitely down here if you look at the column. There's nowhere else to put them. So this line sums to a maximum of 8 if these are 1, 2, and 5. Let's see. So these digits here, therefore, if I look at it, the 7 is gone. So these are at most 6. I don't think that's immediately super helpful. Oh, the 9 is placed in row 7, isn't it? Yeah, I think I'm supposed to now start looking at digits in row 9. Oh, wait, is that, can that be 9? That might be able to be 9. These are from, yeah, from 1, 2, 3, 4, 6. Yeah, I could definitely sneak a 9 in there. Never mind. Okay. What's the largest digit? Maybe I should play this the other way. What's the largest digit I can put on here? And the answer is it's a 6. Because these sum again to a maximum of 2, 3, 4, which is 9. And so 1, 2, 6, you can make sum to 9. You can't use any digits bigger than 6 if you're going to use 2 other digits, because the other 2 digits sum to at least 3. So I can fill in 1, 2, 3, 4, 5, 6. These digits I'm also going to mention, they also are a maximum of 6, because again, the maximum these can sum to is 8, which means these could be as high as 1, 7, but the 7 is gone. So these are 1, 2, 3, 4, 5, 6, and they're not 5. So the reason I'm intrigued by this is that this is now 5 digits that are from 1, 2, 3, 4, 5, 6. In other words, the 7, the 8, and the 9 are getting a little bit tricky to place down here. Also, if there's no 6 in this, there is an outright quintuple in them. Or sorry, there's an outright quintuple of 1, 2, 3, 4, 5. So there's definitely, I guess that's one way to turn it around. There definitely is a 5 or a 6 in here, because if there wasn't a 5 or a 6, these would be 1, 2, 3, 4, and we'd have 5 digits from 1, 2, 3, 4. And if there's a 5 or a 6, that makes these 3 cells sum to a minimum of 1 plus 2 plus 5, which is 8. So these things sum to a minimum of 8. Which means I need the 3 and the 4, right? If I omit the 4, they sum to 6. So I can't omit the 4. And if I omit the 3, they sum to 7. I can't do that either. So that at least gives me a 1, 2 here. That gives me a weirdo 1, 2 pair in the column, actually. Which means that's not a 1 or a 2. And these aren't 1 or 2. But now I've got a 3, 4, 5 triple in column 1, and so therefore that is a 6. Let's do that more dramatically. And therefore that is a 6. There we go, that's much better. So that fills in these, and these are now just 1 and 2, which makes these 3 and 4. So the minimum sum here is now 12. If this is a 5, which it seems like it had better be, because if this isn't a 5, it's a 7, or higher, sorry. If this isn't a 5, it's a 9, actually. If you just look at what digits are left for this cell to be, it's only actually able to be 5 or 9. But 9 is too big, because 9 makes this line sum to 16, and these two can't possibly sum to 16. They're at most 13. So in fact, this is a 5. Which now looks over here and tells me that these are going to sum to 12 out of these digits. So it's not 6 plus 6, and it's not 3 plus 9, so 5 plus 7 is the only way that works. So these are, in fact, 5, 7. That knocks the 5 off of over here. So now these are 1, 2, 4. So this line really does sum to 7. We know it's not 2, 5, so there's just no 2 on it. It's either 1, 6, and that's not a 6, so that's not a 1, or it's 3, 4. This 1, 2 pair is helpful because it sorts out that that's a 4 and that's a 3. And ergo, that's a 4. That's a 3 and a 4. These are 1, 2. Okay, that was great. We've got all of that. Okay, so now we can fill in that 5, 3, 4 over there. Knock out that 5, that 3, 4. That has become a 6. Now the 4 in this row is placed here. Okay, that's a 1, 2 pair. So this is a 3, 4. I actually know that the sum of this is 9, so I should probably use that. So it's 3 plus 4 plus 2. So that gives me a lot of 1, 2s through the grid, bouncing all over the place, which I appreciate. These aren't 3 or 4. Let's see. This is 3 or 4 for the row, for what it's worth. Okay, so let's contemplate what these can be. They can be 1, not 2. They can be 3 or 4, not 5, and they can be 6. And that one's not 3 or 4, so this one's 1 or 6. Oops. That one is not 1. But one of them is 1 and one of them is 6. And then we've added a 3 or a 4. So that makes the total 10 or 11 for what this is. That doesn't immediately spark my imagination. Let's see. Let's do more Sudoku. That's usually the answer. Okay, so these two are a pair. Okay, so let's fill in this pair because we've got a 3, 4, 5 triple in the column. So these are just 7 and 8, which means that digit is a 9, I believe, just by process of elimination. Okay, we know there is a 6 in one of these two cells. These are a known triple, which include a 3. They include a 3 that's there, even. Let's see, we've got a 5, 6, 7. These are an 8, 9 pair, and so I know the order, which bounces around and gives me a bunch of stuff like that. Okay, these are a pair now, 1, 2, 3, 4. These are a 5 and an 8. These are a pair of a 1, 2, and a 6. Okay, but we said the minimum sum here is 1 plus 6 plus 3, which is 10. So this can't be a 1. If this was a 1, it would make this total too small. 1 plus 8 is only 9. So that 2, 6 pair looks over and places my 1 and my 2 over there. Let's see. These are a triple to fill in the last of the things. So we've got 1, we've got the 2, 3, 4, 5, 6. We need a 7, 8, and we need a 9. Okay, so we've got this. Okay, and so beautiful. This is now only a 1. So we can get our 1, 7, 9. That has become a 6, an 8 and a 7, an 8 and a 6, a 2 and a 6, a 5 and an 8. These aren't 6. Okay, and so now that's the 1, just by whatever form of Sudoku you like. These two sum to 10, so I need these to sum to 10, which means that's a 3 and that's a 4. So 3 and a 4, that's a 5 and a 2. 4, 3, 5, 3, and 4, and a very lovely puzzle there from AFrayedKnot. The first AFrayedKnot in the Invitation to Puzzles series, I believe, but hopefully not the last. I really enjoyed that. I should say I actually hadn't done any Region Sumlines puzzles, and so I put out a bat signal for Region Sumlines puzzles, and both Pwin and AFK immediately came forward with candidates for the series. So if you're wondering why there were two Region Sumlines puzzles relatively close, it is because of that. So thank you to the setters for obliging me in covering the puzzle type that I requested. All right, so huge thank you again to all of you. If you enjoyed this, do please like the video, consider subscribing, consider surfing the other videos, and consider becoming a member. It doesn't cost that much, and you can do it, and you can get some benefits like our exclusive Discord. You can vote on what puzzles I do on stream. Where other benefits we're discussing include things like maybe an exclusive Invitation to Puzzles video each week or something like that. I'm not quite sure exactly what that is going to look like, but we'll figure out something for you. But if there's something you want, by all means, let me know in the comments below. But thank you for watching. I'll see you next time. Bye for now.